Hello everyone, welcome back to our channel that is Chemical Engineering. Myself Dr. Kirti Zare. Today I am going to introduce about the Runge-Kutta second order method which is generally useful for the ODE form of the equation, that is the ordinary differential form of the equations. This method having the different type of the applications, right, which can be used into the fluid mechanics, heat transfer, mass transfer. It is also used into the process modeling and simulations, process dynamic and the control. In the physics also, it is useful for the calculating the motions, or you have to check that what should be the graph of that particularly motions. Find out the complex problem of the equation which is present into the ODE form. Again, it can be provided the approximate solution as it is the trial and error method, right? So let us start for that particularly problem. Now here they are asking that dy by dx is equal to x plus 1, which is given y is equal to the 0, x is equal to the 0, and they are giving the h is equal to the 0.1. Find the yj whenever the xj is equal to the 0.2 using the Runge-Kutta second order method, right? So Runge-Kutta second order method. So in that you are supposed to use the two coefficient or the coordinate of the Runge-Kutta. In my next video, I will uploading the Runge-Kutta fourth order method. So in that you are supposed to use the four coordinate of the Runge-Kutta method. Solution of this particularly problem, which is mentioned as h is equal to the step function or the size function. So h is equal to the xn minus x0 by the n, right? So h value become the 0.1 is equal to xn is 0.2 minus x0 is the 0 and n, right? So you are supposed to calculate the what should be the n. So by simple calculation you are getting n become the 2, right? So n become the 2. So you have to perform the 2 iteration over there, right? Hence actually this is the approximate method. So in that you can go for the for the number of the iteration as per the provided by the problem statement, right? So now let us start for this calculation. Firstly, you have to calculate the K1 as the coefficient or the constant that you are supposed to use to the Runge-Kutta method, which is calculated as K1, that is equal to the H, which is the function of the x0 into the y0, and the K2, which is the function of the H multiplied by the x0 plus H into y0 plus the K1, right? And the K become the 1 by 2 K1 plus the K2, right? And Yj value become the Y0 plus the K. So this is the simple solution of this particularly Runge-Kutta second order method, right? So let us start for this calculations because they are asking for the two iteration only. Accordingly, this particularly type of the formula. So you can go for the two iterations only for the iteration number 1, right? So in that you are supposed to calculate the K1 first. So K1 is equal to H. So H value become the 0.1, which is the function of x0 and the y0. So it is the given, that is the 0 plus y0 become the 1. So simply calculation you are getting the value become the 0.1. Second value, that is the K2 is equal to the 0.1 into bracket, which is the function of the x0 plus the 0.1, that is the H value, into bracket y0. So y0 become the 1 plus K1 become the 0.1, right? So this is the K2 value. So just doing the simple calculation, you are getting the K2 value become the 0.12, right? Now let us start for the calculation of the K, that is 1 by 2 K1 plus the K2. So 1 by 2 into bracket 0.1 plus 0.12, right? So for calculation you are getting this value become the 0.11, right? So K value become the 0.11. Calculate for the Yj, that is equal to Y0 plus the K, right? So now you have to put the Y0 value, that become the 1. 1 plus 0.11. So you are getting the Yj value become the 1.11. Right? It become the 1.11. Now let us start for the iteration number 2, because accordingly this you are supposed to go for the 2 iterations, right? So just start for the iteration number 2, right? In the same manner you are supposed to calculate the K1. So it become the H. So H value become the 0.1. Now which is the function of the x1 to the y1? So now what is the value of x1? So x0 become the x1. So it become the x0 plus h. So this value become the 0 plus 0.1. Now you have to take this x1 value become the 0.1 here, right? So x1 is the 0.1, right? Accordingly our function, so 0.1 plus y. So y1, yj value become the now y1, right? Yj value become the y1. So again you have to take the yj value become the 1.11. 0.121. Go for the calculation of the K2. So it become the h. So h value become the 0.1, which is the function of the x0. So x0 value become the now 0.1, right? Plus h, that become the again 0.1, plus y0 become the y1, that is 1.11, plus k1 is the 0.121, right? So K2 value become the 0.1431. Okay. Now just calculate for the K. So K become the 1 by 2 K1 plus K2. Right. So 1 by 2 into bracket 0.121 plus 0.1431. So K will become the 0.1320. Right? Now just go for the calculation of the yj. So it become the y0 plus the k. So now what is the value of y0? So that become, consider the, because y0 is equal to the y1, which is again is equal to the yj. So this value become the 1.11 plus k, that is 0.120, and if you are calculating this yj 242. Right? So yj become the 1.242. So this is the total calculation up to the iteration number 2 as per the requirement of this. Right? So if you understand this particular type of the numerical, so please subscribe the channel Chemical Engineering. Please like my video, share it, and if you have any doubt, so you can also put into the comment box, so I will get the solution of that particular differential form of the equation. Thank you so much for the watching.